handing out these last papers. So, you are going to, how do you graph a function? Plot the ordered pairs. What are the ordered pairs? That's your x, y that make the equation work. And most of the time, what I'm going to ask you to do, as we do the ones today, is to make a table. And when we make that table, your table is going to look like an x, y table. And I will specifically tell you to pick 2 x values, or 2 positive values, 2 negative values, and then we will look at picking 0 always. And you did this last year. And so this is not like something you haven't seen. So as you're looking at this, it says, when you've plotted some, then you might notice a pattern. Like it might make a straight line, or it might be a curve, okay? So we're going to make this XY table, and I'll tell you the easiest numbers to pick, and a lot of times we want to pick numbers close to 0. Just because when we go to graph them, we want them to be nice and close to our origin and our x and y axis, so we don't have to make a massive graph, right? If you have points way out, you have to make a pretty big graph. Okay? So we're going to plot those ordered pairs. We're going to make this XY table. My hint today is to pick numbers like 2, 1, 0, -1, -2. Okay? You can pick other numbers, and sometimes it makes sense to pick a multiple of numbers or different things. Okay? The x's are independent. You get to choose them. You need me to go back to that? Okay. So again, as we're looking at this, you're plotting the ordered pairs. So the most important things that I'm looking at here is that you're plotting all the ordered pairs that make it work. That's my x, y. And the easiest way is make the equation. Once you plot the points, you're going to notice a pattern. Either it's a straight line or a curve. For real-world problems, sometimes you will only have ordered pairs, because it doesn't make sense to have a line, correct? Now, these last 2 quizzes for this unit, the B1 and B2, I have yet to put those in Power School, right? I haven't put them in the grade book. I will be putting them in soon. So as you're taking a look, and if you know that you didn't do that great, you might want to make sure you're starting to come in. So Zach, you don't have to have everything word for word. You're okay. Okay. So on the next part of this, we are looking at a continuous function, and the graphs will be, and the notes will be on the daily plan. Continuous function is when our graph is unbroken. Neither a line nor a curve, either line or curve. So continuous functions is when you have that line like this. This is continuous, right? Most of the time, continuous is when you can have a fraction or a decimal of something, okay? So if you're thinking, oh, I could have a fraction or a decimal of that, it's probably going to be continuous. Like heating times in minutes, right? You can check it at 0 minutes, 1, 2, 3, 4 minutes, but you can also, Mason, check it at 1.5 minutes or 1.25 minutes or 2.3 minutes, right? You can stop your stopwatch. So this is going to be a continuous graph. Do I need to move you guys? You okay, Keegan? No. Okay, good. So discrete is when our graph is composed of distinct isolated points, okay? Cartons of milk sold, right? And the money that we spent. You cannot go into the grocery store and say, I want a half a carton of milk. You're either buying a gallon, you might buy a half gallon, you might buy a pint, but you can't go in and say, I want to buy half of a container, right? Whatever that carton is. So, thus, this graph is going to be discrete. And the question that you're always kind of trying to think about, how do you decide if something's continuous or discrete? You're going to decide on the reasonable values for the independent variable. That's your x values, right? Independent is always your x values. So when we're looking at this, if it is continuous, that's when you can have 3.3, 3.7, right? That's my continuous graph, right? If it is discrete, that's when you can only buy 3 cartons, 4 cartons, right? I can only buy so many whole numbers usually, right? So the discrete is a lot of times when we think of our whole numbers that we can use, okay? That's what you're going to try and decide. So your homework, you're going to be asked continuous or discrete. You're going to be asked if it's linear or nonlinear, okay? You're going to be looking at graphing a function. Now, this is an absolute value function, right? So it says you can make a graph for any equation by making a table of values, then plotting the points. And we're going to plot them as we make them. So we are going to start with a positive value of 2. We're going to have 2, 1, 0, negative 1, and negative 2. Could I have picked a fraction for this?
Yes.
Yeah, I could. So maybe we want to pick negative 1.5, right? That's going to be between here. Negative 1.5. We'll put that down for 1. Usually I'm going to need you to do 5 values on your table, okay? So you're going to go to the equation. So in your homework, you might even want to write the equation right behind here, and then you're going to show your work. So what's the work for this one? The work is, we're going to take the absolute value of, so put the absolute value signs. It said 2. Absolute value of 2 minus 4. The absolute value of 2 is actually just 2. 2 minus 4 is negative 2. Please plot that point at 2, negative 2. Okay? You are now going to plug in 1. The absolute value of 1 minus 4. Well, the absolute value of 1 is 1. That's the distance from 0. 1 minus 4. And for some of you, if it helps you to write this as plus a negative, should be negative 3. Remember, subtraction is the same as adding the opposite. So we get negative 3. So we're going to go 1, negative 3. Okay, plot your point as you're putting these in. Now we have 0 for x. You got to choose these. These are your independent variables, right? Our domain. Y is equal to absolute value of 0. Well, how far is 0 from 0? It is 0. So 0 minus 4 gives us negative 4. And at this point, if we were going to stop at this point, we might put down linear or nonlinear. We might put linear, and we're wrong, right? This is not a linear graph. Because now, and especially if you would only do the positive points of this, you are never going to see that when we plug in negative 1. So we're going to plug in negative 1. We plug in negative 1, y is equal to the absolute value of negative 1 minus 4. Absolute value of negative 1 is not 3. Absolute value of negative 1 is 1. 1 minus 4 is negative 3. So at negative 1, it's at negative 3. And we're going to continue. Y is equal to, just write it down at the same time. Show all this work on your paper, please. Minus 4. So those of you not writing this down, I kind of need you to put this, because I don't necessarily need this in your homework, but we're taking this test next week, and next week, Wednesday, is when we're taking the test. And this next couple of days, you're going to finish the unit, but you need to make sure that you're understanding all this for this test. So we are looking at 2 minus 4, and we get negative 2. Right? If I wanted to plug in 4, if I would have gone and put 4 in, where would 4 have been? If I would have plugged in 4, 4 should be where? 0. Later this year, we're going to talk about roots of functions. This is a root. If I would have plugged in negative 4, what else would I get? I'd get 0 also. Well, we said negative 1.5, right? If I would have plugged in negative 1.5, negative 1.5, the absolute value of that, minus 4, that's just 1.5 minus 4. Whereas a negative 1.5 minus 4, it's like right here, right? In between negative 1 and negative 2, it's like at negative 2.5, right? In between these two. So now please take your straight edge or the edge of your book, edge of something, and we are going to make our graph, right? And we are connecting those points with a nice straight line. And should we have arrows on our graph? Yes, we should. So when you do your homework tonight, the first question 9, 25, and 27 look just like this. So 9, 25, 27. I give you an equation. I ask you to graph it. You want to make this same XY table for 9, 25, and 27. You then want to make a Y and X axis on the graph paper. Then it's going to ask you, what's our domain? So our domain for this, what are our X values that we can put in? We can put in fractions and decimals, right? We have these arrows on here from that worksheet earlier that you guys that I handed back. What would you say our domain is? Our domain is all real numbers. All real. Our range is not all reals. Can we have -10 for a range?
No.
What's the lowest number we can have for our Y? So we want to say our lowest number is at -4, so our range is Y is greater or equal to -4 for all real numbers. Now, sometimes for all real numbers, you will see mathematicians use something like this, this capital R, like this. So that is for saying all real numbers, okay? So kind of shorthand, they use that. It usually has the 2 lines, not just an R, but there's like specifically 2 lines. So that lets people know, oh yeah, that's real, not all real numbers. Is our graph continuous or discrete? Continuous. And then the last question is asking you, is it linear or nonlinear? And it is definitely nonlinear. Now again, if you would have only graphed the positive ones, you might never see the V in this. And if you've gone to Desmos calculator, and I saw some people were putting in some different equations, put in some absolute value ones and see what they look like. Put numbers inside, like with X minus the absolute value, and do some with X outside with plus or minus. And kind of see how those look, okay? So the next part that you're going to be asked in your homework, and this is like number 23 that you're asked to do, it says make a graph that describes described below. Be careful even when determining whether or not to connect the dots. So the first one, the farmer's making a cheese wheel. His recipe calls for the ratio of 1 gallon of milk to 16 ounces of cheese. So he uses no milk, right? Zero gallons of milk, 0 ounces made, right? He uses 1 gallon, 16 ounces. Please graph, check with your shoulder partner to see at 2 we're at 32, right? 3 we're at, no. 3 we're at 48, right? Okay. Could I use half a gallon of milk and make some cheese?
No.
Yes, I could measure in a cup a half a gallon. Could I use 3.5 gallons of milk?
Yeah.
Yes. If I use 3.5, it's probably going to be right here, right? So if we are looking at this one, are we talking continuous or discrete?
Continuous.
We are talking continuous. This graph, we actually want to have a line, okay? And that one line should have an arrow on the end because I want to know that it is not stopping, but it is continuing, okay? So we've already talked about this part. My graph is continuous, right? We are asked, what is our domain? It is not all real numbers. Because we can't use a negative gallon of milk, right? So in this one, we might say our value is when X is greater or equal to 0 for all real numbers, right? What is our range? That's my Y value. My range is when Y is greater or equal, exactly right. Greater or equal to 0. And again, we can have fractions and decimals, right? So we're going to say for all real numbers. And we already decided this should be linear. Right? So reading that next situation, Keegan, please read.
Okay.
Farmer sells wheels of cheese for $9 each. You cannot buy part of the wheel.
So he doesn't sell any 0, 0, right? That's just kind of a given. He sells the first one, 9, right? So a little above 8, between 8 and 12, right? At 2, he sells it for 18. 3, we're at 27. 4, we're at 36, right? And then I'm going to take and connect it with the line, right?
No.
Why not?
No, because you cannot buy part of the wheel.
Because we cannot buy part of a wheel, right? So, this one is definitely discrete, okay? Now, sometimes on this last dot on our graph, or sometimes they might like put an arrow with that, even though there's no line, just to kind of show that it goes on and on. But I'd be okay either way if you leave it with just the dot or if you have an arrow there. We want to identify what is our domain. So right now to your shoulder partner, check and see what you think your domain and range. It's a little different. It's close, but it's a little different.
0.
So domain. X is greater or equal to 0. Like we could sell nothing, right, and make no money. Y is greater or equal to 0. Someone said, well, really just greater than 0, because like if you don't make anything, I would take either one. I'd take greater or equal to 0 or just greater than 0. But it is definitely not all reals, right?
It's for all wholes.
It is for the whole number. Right? And someone said, well, if I didn't want to say whole numbers here, could I say multiples of 9? Yes, because it is going to be better, right? Multiples of 9, but I'd be okay with, again, greater or equal to 0 for whole numbers. Okay? And you agree that it is linear again, right? We sell more, it's exactly making a nice straight line. Okay? Top of the next page. Of your notes. Okay? So, writing function rules. This is why you have page 265 from 12 to 18, because you're writing function rules. Now, this leads right into the quiz that we took yesterday from B2. So we'll talk about that kind of as we finish up these last couple examples. So, key identifying information. First off, when you're writing a function, rule, or equation, I'll take your answer either one of these two ways. I'll either take it as a y equals, and you write the equation, or I'll take it as like f of x equals. So when you do page 265, that's what I'm looking at on page 265. That you either tell me y equals, or you put it as f of x or g of x or whatever the story happens to be. Okay? In this one, when we read the situation, it says, you can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees more than 1/4 the number of chirps the cricket makes in a minute. So what is our key information? There's a couple of pieces of key information in this one. The first one is the temperature is 40 degrees more than 1/4 of the number of chirps. Right? So the temperature is 40 degrees more. So it's that whole sentence, right, that we were looking at, that last sentence. That is going to help us write our equation. Now, you guys wrote equations last year. Identifying our key variables, right? So this is kind of key, and then we're going to talk about kind of some of the key words that you're looking at. So when we are looking at this, identifying our key variables in this one, well, I'd probably go with T for temperature and N for the number of chirps. Some of you will like to use Y, and you'll like to use X. Some of you will use maybe T of N, right? And then this would be your N. I don't care what you use for your variables, but you have to assign them something. So temperature, and in this case, the number of chirps in a minute. Hale.
If it's dead, is it 40 degrees out?
We're just looking at this situation, comparing the terms. So if we're looking at this one, if we want to write an equation, so going back to the story problem, the word is almost always in mathematics is your equal. The word of is almost always going to be our multiplication. More than. It does not say is more than. It just says more than. More than would be addition, right? Okay? So when we're thinking of more than, less than is a special one. You got to switch the order, but more than you usually don't. So the temperature is, so T, right, equals 40 more than. So we are looking at T, right, equals, is our is, 40 more than is, plus 1/4 n. Could you have this one, T of n, equals, because that's saying that function notation, right? 40 plus 1/4 n. Same as this equation, right? Those two are the same. Could you have had y equals 40 plus 1/4 x? So I need to move you guys? Okay, go talk. All that's picked up on the recording, so I get to hear your conversation. So does everyone else when they listen to the video. Okay. So this one's a lot easier. I even have it set up for you. So read through this. The landfill has 50,000 tons of waste in it. Each month it accumulates an average of 420 tons more waste. What is the average rule that represents the total amount of waste in M months? So they pretty much give it to you in order. Fill in your variables, please. Do that right now. Fill in your numbers as you are taking a lesson. Look at your vocabulary, the landfill waste, what's happening, and you're writing this equation. So, comparing functions that are displayed differently. These last two, and then we're going to get you started. So, when you are, says Sean and Jack both like apples. Each week they buy a certain number of apples at the grocery store. Write 4 things to compare and contrast. And I know that both Mrs. Ives and Mr. Holquist, when they're looking at you writing things, it would not just be like putting down a one-word answer. So, Sean, the equation is f of x equals 6x. So if I asked you after 1 week, how many apples? 1 week would be 6 apples, right? If I said in 2 weeks, we'd have what?
12 apples.
Okay, so you're just using that equation, right? 3 weeks would have been 18, right? Apples. Here's Jack's. So when I look at an equation, I could have made that same table that I had here, right? So this is kind of the table of the x and the y. So when you look at an equation and you're thinking on the test and you have to write things, and this might be like a 8-point question because I'm looking for you to expand and tell me these things that, you know, what are the 4 things and explain why they're different and why they're the same. So then I look at Jack's situation, and Jack has, looks like 1 week 4, 3 weeks 12. And so we start looking at this, and it looks like that as x increases by 2, our y increases by 8. Okay? And again, so when we think about functions and we think about linear, nonlinear, we might think about our rate of change. And our rate of change for this one is what? What is our rate of change?
Times 4.
So we are looking at the change in our y, right? So triangle y, change in y divided by change in x. And the most common mistake is that people think it's 8. He's buying 8 more a week. Is he buying 8 more a week?
No.
He's buying 8 every 2 weeks. He's buying 4 apples, right, per week. So if we are looking at this, we could put in right here in our table, right? They kind of skip numbers. Could you figure out what in 2 weeks that he had 8? And in 4 weeks, he bought 16, and in, right? We could fill that in. They left that out. Here's what I'm looking for you to do some writing with, right? Possible answers. If we're comparing these 2 things, we might say they're both linear, right? So Nick, you're writing this down. So as we are looking at this, they're both definitely linear, okay? Yep, top of the next page. Both are discrete, right? We can't have half a week when we're looking at this, right? Are you writing, Hale? Yeah. Yep, good. So looking at each week that they're discrete, the domain of each one are positive whole numbers. The range, again, positive whole numbers, no negative. And this one is incorrect. Jack buys not more per week, he buys less. And can you see what the mistake was? It says she buys 6 a week and he buys 8. They were just looking here that it increased by 8, but his actually is 4 per week, right? So we can say Sean buys 6 per week, Jack buys 4 per week. On a week, and so you could have picked, oh, 1 week I saw up here, Sean had 6, Jack had 4. You could have picked on the second week, Sean had 12, Jack had 8. So those would be other things that you could tell me, right, that you could compare. So when you are asked, I would write all of these in your notes, right? Because when you go to take the test, and I say, hey, how are you looking at comparing and contrasting? Having this whole list is the kind of stuff that's going to take you to that. If it's a 8-point question and then you just put down like a 1 or 2 word answer, this is taking you to that next level, okay? So if you're trying to get all those points, that's what I'm looking at, okay? So both are linear, both are discrete, the domains are both whole numbers, the ranges are whole numbers. What's really different is that how many apples each person is buying per week, right? That is the contrast part. There really wasn't much else. Both, besides that, both are pretty similar, okay? This last part, they give you 2 things. It says your parents have said you have 2 different types of representing a class looking at our functions. Your parents signed you up for a music download service to get music on your phone. They said you have to pay for it. Here are the 2 companies you're deciding between. Look at their pricing plans below and compare them and answer the questions. So, if we are looking at it, first up, is each function, if I want you to label each function and you can kind of check with your shoulder partner, is it continuous or discrete? Linear or nonlinear? So put that next to each one. Put those words. What do you think? Okay? Then check with your shoulder partner. Write it down and then kind of check with your shoulder partner as you're looking at it. Should have been continuous or discrete? Discrete. Linear or nonlinear? Non. Okay? Doesn't make a straight line. If we are looking at this one, continuous or discrete? Should be discrete. Linear, nonlinear? Linear. Our variable is to the first power, right? Okay, so when we look at equation, variable to the first power. So, now we're looking at Donnell's. Donnell's company charges how much per song? For 1 to 5 songs, how much do they charge? $1. $1. But if you buy 6 or more songs, then what are they charging you?
1/4 of the dollar.
Yeah, but we wouldn't say that.
25 cents.
They are charged 6 or more, 25 cents per song, right?
And how come it goes like that? It goes like
Oh, so why does it go if we look at this? So at 5, right, it's here. And then here it's at 9. So after 4, so that's why we said 1/4.
And she jacks up the price.
Okay? And it looks like, nope, it goes up another 25 cents per song, right? That's still, there's 4 dots in between there, right? So it takes us 4 more songs to get to the next dollar value, right?
That's straight from the far one to.
But if you just look at your paper and look at the graphs there, it's right there.
Yeah, I know, but
But do you think it's easy to graph the 1/4 maybe? Yeah, but this part, we're not talking about this. We put this down. We said 1 to 5 songs, $1 each. Did you put that down? Okay, so then it's for 6 or more. JD's is always charging $2 a song.
Yeah, that's
Oh.
very cool.
Okay? Doesn't matter how many buy, $2 a song. Why does it start at 4? That's like the membership fee, right? Or that's like the initial, sometimes initial fee that they charge is possibly $4, right? And then after you pay $4, it's $1 a song for the first 5 songs and then 25 cents after. This is what I was thinking was kind of leading into your quiz, is it says, well, what's C of 5 for each company? Well, if you look at Danelle's C of 5, that means at 5, how much did they charge?
They charge
$9. This is the answer, okay? C of 5 equals 9. That was for Danelle's.
C of 5 equals.
Now, for JD's, C of 5, and this is where some of you, I was like, what are you doing? Like, did you even do B2 assignment? The equation was 2S, right? And we replaced 5 with the number of songs, right? So what we should be doing is taking this to be 2 times 5. Well, I saw some people put this answer of C of 5 equals 10. And then they went back and they divided everything by 5. Right? This is the answer. This is saying for 5 songs, the cost is $10, right? So some of you, I'm not sure if when you did B2, you understood that quiz or not. But when you were doing these, you could have used your calculator. So like when I look at number 2, H of 12, I was looking at you putting in 2/3 times 12 plus 4. And you could have used your calculator. So you could have put in 2 divided by 3 times 12. Or you could have done this and go, oh, 3 goes into 12 4 times, and that gives me 8 plus 4. And the answer for H of 12 is 12. And when you plug in 1/5, I don't care if you use the decimal or if you use a fraction, and you could have plugged that in G and take 5 times 1/5, but you could have used 1/5. And I saw many people go, oh, I think this has to be 12. Like for question number 1, I had people say 8 equals 5x minus 8, and they solved it. No, it's G of 8, and you're replacing the x. So if you're not understanding these, please make sure you're getting in here and getting some help on them, okay?